The numerical problems based on the chemical kinetics of first order reaction or integrated rate equation of first order reaction and half-life period of first order reaction. Then consider the first problem. Consider the first problem. Consider the first problem. Rate constant. The rate constant. The rate constant of first order. Rate constant of first order reaction. Rate constant of first order reaction is 3.2 into 10 raised to minus 3 per second at 25 degrees Celsius. Find the time required for to complete 80% of reaction. 80% of reaction. Then consider this is the first numerical problem. The rate constant of first order reactions are given. Then consider the solution. Then what are the given values? The rate constant of first order reaction is given. The K1 is equal to 3.2 into 10 raised to minus 3 per second. The rate constant value are given. Then consider the second part of this problem. Find the time required to complete 80% reaction. Then how much time required to complete the 80% reaction? A is given 100%. A is 100%. X is 80%. The initial concentration of reactant is 100. Out of this, 80% is reacted. Then what is the time required to complete the 80%? This reactant concentration is X. Initial concentration is 100. What is find the time required to complete the 80% reaction? The reactant concentration is 80%. Is X is 80. Initial concentration is then 100. A minus X is equal to 100 minus 80 is equal to 20. Then determine the time T. Then what is the time? How much time required to complete the 80% reaction? The K1 is known. Initial concentration is 100. Reactant concentration is 80. Then A minus X is unreacted concentration. It is a 20. Then what is the time required to complete the 80% reaction? Then by knowing, using the rate constant equation for first order reaction, K1 is equal to 2.303 divided by T log A upon A minus X. Then we can rearrange this. P1 is equal to 2.303 K1 log A upon A minus X. Then T is equal to, then T is equal to 2.303. The K1 is given 3.2 into 10 raised to minus 3 per second. Log A is 100, A minus X is 20. A minus X is 20. Then T is equal to 2.303 divided by 3.2 into 10 raised to minus 3 log 5. Then T is equal to 2.303. Then what is the value of log 5? The log 5 is 0.6989 and it is divided by 3.2 into 10 raised to minus 3. Then solve this. We can obtain the time required for completion of 80% reaction. 2.303 into 0.6989 divided by 3.2 into 10 raised to minus 3 is equal to 502.98 per, this is the second. This is 503 seconds. This is the time required for completion of 80% reaction. In this problem, rate constant value is given for first order reaction. K1 is equal to 2.303 into 10 raised to minus 3 per second. Then we will determine the time required for 80% completion of reaction. Reactant concentration is given in the percent 80. The initial concentration will be 100 and unreacted concentration is A minus X. 100 minus 80 is equal to 20. Then what is the value of T? Then we can determine the T by using integrated rate equation. K1 is equal to 2.303 divided by T log A upon A minus X. Rearrange this equation. T is equal to 2.303 divided by K1 log A upon A minus X. We substitute the value of K1. Value of A 100, value of A minus X is 20. Then T is equal to 2.303 into log 5 divided by 3.2 into 10 raised to minus 3. By solving this, we get the time required for completion of 80% reaction is 503 seconds. Then consider the another problem. Consider this another problem. Then consider the another problem. This is the second problem. Half life period. The half life period of certain reaction. Half-life period of certain reaction is 80 minutes. The half-life period of certain reaction is 80 minutes. How long will it take? How long will it take for the reaction to 80% 80% completed. 80% completed. Then consider this problem. In this problem, the half-life period of first order reaction is given. The half-life period of certain first order reaction is given. It is 80 minutes. Then consider the solution. The given half-life period of given first order reaction is given. It is 80 minutes. Then second part of this problem, then how much time required for completion of 80% reaction? Then what is the time? How much time required to complete the 80% reaction? Then how will you determine this? The time required to complete the 80% reaction. For this given, for the given reaction first, the rate constant will be known. We can first determine the rate constant by using this half-life period. Rate constant and half-life periods are related to each other by equation. K1 is equal to T 0.693 divided by T half. Then K1 is equal to 0.693 divided by 80 minutes. Then K1 is equal to, consider 0.693 divided by 80 is equal to 8.66 into 10 raised to minus 3 per minute. For given reaction, we can determine the rate constant by knowing the half-life period. The half-life period is given. With the help of this half-life period, we can determine the rate constant by using this equation. Half-life period and rate constant are related to each other by this equation. K1 is equal to 0.693 divided by T half. And consider the second part of this problem. 80% reaction is completed. What are the given value? 80% reaction is completed. 80% reaction is complete. This, if initial concentration is 100, then X is 80. Reactant concentration is 80. And then A minus X is equal to 100 minus 80 is equal to 20. If A is known, A minus X is also known, and rate constant is known, then we can determine the time required for completion of 80% reaction by using integrated rate equation of first order reaction. K1 is equal to 2.303 divided by T log A upon A minus X. Then T is equal to 2.303 K1 log A upon A minus X. Then we can substitute the value 2.303. The rate constant is 8.66 into 10 raised to minus 3 log A is 100, A minus X is 20. Then T is equal to 2.303 log 100 by 20 is log 5 divided by 8.66 into 10 raised to minus 3. The T is equal to 2.303. What is the value of log 5? The log 5 is 0.6989 divided by 8.66 into 10 raised to minus 3 then T is equal to, we can solve this, 2.303 into 0.6989. The 69 is a 6989. The log 5 has 0.6989. Then we can solve this, 2.303 into 0.6989 divided by 8.66 into 10 raised to minus 3. 2.303 into 0.6989 divided by 8.66 exponential into 10 raised to minus 3 is equal to 185.86 minute. This T is equal to 186 minute. Then T is equal to the time required for completion of 80% reaction is equal to 186 minutes. In this problem, half-life period for first order reaction is given. By knowing the half-life period, we can determine the rate constant. In the second part of this problem, what is the time required for completion of 80% reaction? Reacted concentration is 80%, then initial concentration is 100, reacted is 80, then A minus X is 20. By using integrated rate equation for first order reaction, 2.303 divided by T log A upon X, to rearrange this equation, T is equal to 2.303 divided by K1 log A upon A minus X. We substitute the value of K1, A minus X, and we can solve this. Then finally we obtain the time required for completion of 80% of reaction, and this T is equal to 186 minutes. Then consider the one more problem. Consider the next. Consider one more problem. The rate constant, consider this problem third. Rate constant for first order reaction. The rate constant for first order reaction is 3.9 into 10 raised to minus 3 second. 3.9 into 10 raised to minus 3 second. Find the time required. Find the time required to complete 95% of reaction. For the first order reaction, rate constant is given, and consider this solution. The rate constant is given, K K1 is equal to 3.9 into 10 raised to minus 3 per second. And what is the second part of this problem? Find the time required to complete 95% reaction. And what is the time required to complete the 95% reaction? To determine the time required for completion of 95% reaction, we will be know the rate. We will be know the this directly rate constant are given. Initial concentration is given 100. Reactant concentration is 95. Then unreacted concentration is A minus X. 100 minus 95 is equal to 5. Then rate constant equation for first order reaction is 2.303 divided by T log A upon A minus X. We rearrange this equation. A minus X and K1 is known, given. Then we can determine the time. Time T is equal to 2.303 divided by K1 log A upon A minus X. Then we substitute the value 2.303. The K1 is 3.9 into 10 raised to minus 3 log A is 100 and A minus X is 5. Then T is equal to 2.303 divided by 3.9 into 10 raised to minus 3 into log 20. Then T is equal to 2.303. Then what is the log of 20? You can log 20 is equal to 1. Log 20 is 1.3010 divided by 3.9 into 10 raised to minus 3. We can solve this. 2.303 into 1.3010 divided by 3.9 into 10 raised to minus 3. Then P is equal to 768.25 seconds. This is the time required for completion of 95% of reaction. This is the rate constant is given, initial concentration, reactant concentration is given. Then we can determine the time required for completion of 95% of reaction. For 95% completion of reaction, the 768.25 seconds are required. Then consider the one more problem. Consider the another problem. Then consider the one more problem. Show that in case of all first order, show that in case of all first order reaction, show that in case of all first order reaction, the time required for 99.9% completion is 10 times is 10 times is a 10 times that of required for the half of the reaction take place. Then consider the first, read problem carefully. Then what we want, show that in all first order reaction the time required for 99% means the T 99.9% is equal to 10 times the times required for half of the reaction. This 50% reaction we can represent this T half is a T 50%. This time we show the time required for 99.9% completion of reaction is 10 times the time required for half of the reaction. We can show this T 99.9% is equal to T 10 T half. And consider the first. What is the value of half-life period? The half-life period for the time required for 50% completion of reaction. Half of the reaction means it is a 50%. We can also represent by T half. The time required for 50% completion of reaction is 0.693 divided by K1. It is a first order reaction. It is equation 1. The time required for completion of 50% reaction T 50% T half is equal to 0.693 divided by K1. Then what is the time required for 99.9% reaction? Means A is 100. Then A minus X. The 99.9% reaction is completed. Means X is a 99.9%. A is 100. Then A minus X is a 0.1. Then we can determine time required for completion of 99.9% of reaction. The T 99.9% is equal to, what is the rate constant equation? Then general rate constant equation is K1 is equal to 2.303 divided by T. What is the value of T? We can determine the time required for 99.9% completion of reaction. Log A upon A minus X. We can rearrange this. T 99.9% is equal to 2.303 divided by K1 log A upon A minus X. We can substitute the value of A and A minus X. The T 99.9% is equal to 2.303 divided by K1 log A is 100 and A minus X is 0.1. Then T 99.9% is equal to 2.303 K1 in log 100 divided by 0.1 is equal to 1000. The log of 1000 is 3. Then T 99.9% is equal to 2.303 log of 1000 is 3 divided by K1. Then solve this. T 99.9% is equal to 6.909 divided by K1. Means 2.303 into multiplied by 3, it is a 6. The 3 into 2.303 is equal to 6.909. Is the time required for 99.9% is equal to, this is the equation 2. Then we can directly write this by solving this. It is equal to 6.909 divided by K1. This is the equation 2. Divide the equation 1. Divide the equation 2 by 1. We can, the T 99.9% divided by T 50% is equal to 6.909 divided by K1. Then what is the value of T half? 0.693 divided by K1. This K1 get cancelled, is equal to 6.09909 divided by 0.693 is equal to, then we divide 6.909 by 0.693 is approximately 9.69, which is approximately equal to tens. Means the T 99.9% divided by T half or T 50% is equal to 10. They show that the time required for 99.9% completion of reaction is 10 times the time required for 50% of reaction. In this problem we can show the time required for 99.9% completion is 10 times the time required for 50% reaction. T half is a 0.693 divided by K1. 99.9% reaction is completed. X is a 99.9, A is 100, then A minus X is 0.1. Then K1 is equal to 2.303 divided by T 99.9% log A upon A minus X. We rearrange this equation. T 99.9% is equal to 2.303 K1 log 100 divided by 0.1. 100 divided by 0.1 is 1000 and the log of 1000 is 3. 2.303 into 3, 6.909. The T 99.9% is equal to 6.909 divided by K1. We divide the equation 2 by 1. We can obtain the time required for 99.9% completion is 10 times the time required for 50% of reaction. Then time required for completion of 99.9% reaction is 10 times the time required for 50% of reaction. Then consider one more example. Consider one more example. Consider one more example. Show that show that in every first order reaction, the time required for 75% reaction, 75% reaction is double the time required for 50% of reaction. The 50% of reaction. In this problem we can show the time required for 75% reaction is double the time required for 50% of reaction. Consider the given X is reactant concentration, X is equal to 75%, then A is 100, A minus X is 100 minus 75 is equal to 25. Then we can determine time required for 75% completion of reaction. T 75% is equal to 2.303 divided by rate constant log A upon A minus 6. We can use the rate constant equation. K1 is equal to 2.303 divided by T75 log A upon A minus 6. This equation will rearrange. T75% is equal to 2.303 divided by K1 log A upon A minus X. Then T75% is equal to 2.303 K1 log 100 divided by 25. T75 is equal to 2.303 into log 4 divided by K1. The T75% is equal to, and what is the value of log 4? Log 4 is equal to 2.303 into 0.6020 divided by K1. Then T75% is equal to, the first part, the T75% is equal to 2.303 into 0.6020 is equal to 1.3864 divided by K1. This is equation 1. Then what is the time required for 50% completion of reaction? The T50% or T half is already known, 0.693 divided by K1. This is the equation 2. We can determine the time required for 75% completion reaction is equal to 1.3864 divided by K1, and the time required for 50% completion of reaction is equal to 0.693 divided by K1. Then divide the equation 1 by equation 2. We can divide T75 divided by T50% is equal to 1.3864 divided by K1 divided by 0.693 divided by K1. This K1 get cancelled, is equal to 1.3864 divided by 0.693. Then 1.3864 divided by 0.693 is equal to 2. This show that the time required for 75% completion of reaction is double the time required for 50% of completion of reaction. This show that the time required for 75% completion reaction is double the time required for 50% completion.